Stephanie asked, or sorry, don't even pick you out. A inquiring student asked, so the we shouldn't have it. The rules for determining oxidation states won't be given on the exam, and that's right. You need to know how to determine oxidation states. The rules won't be provided. Just like what we're going to talk about today, this won't be provided either on the exam. But if you do this, if you do your homework, you're going to know this. Just like if you do your homework, you know the rules for the oxidation states. And if you're not comfortable with this, man, come by. Please, I can work with you. And this exam retake really went well. So there's only a few folks that I'd really like to yank in here and say, look, come on, let's right, help you out. Because everyone is doing okay. Just a few we need to get on their case. Okay? So, redox reactions. So why is this a big deal? Well, they're everywhere. You just don't see them. They're inside a battery, for example. And once you use up the reactants, well, then the battery's dead. But the point is, they're redox reactions. So there's this whole transfer of electrons idea. Well, you can use that, right, to run a toothbrush, to run cell phones, right? Batteries. There's just one use. Little sensors to monitor enzymes in cells. I mean, there's a gazillion uses for redox reactions. Okay, but the point is what we're going to do is balance them. I really like this because I like order. I like to have a logical sequence of steps because I know if I'm doing things right or not. This is nice. Before we just balanced, okay, let's see, there's 2 NAs on this side, there has to be 2 NAs. Let's just randomly put stuff, numbers on both sides. The stoichiometric coefficients, right? We're messing with them. And you randomly mess with them until finally it gets balanced. Not now. Now there's actually going to be some order, some method to the madness to balance these things. And here's the rules. Well, I say we just, and you've got them, so let's just jump into this and see if it works. Now, right off the bat, we see an unbalanced reaction. And we could, I mean, right off the bat, you see like the 3 oxygens in the nitrate? Well, how are we going to get oxygens in there? Right? So the steps are going to take care of this for us. Another thing is it says, oh, it's an acidic solution. Right? Inside your cell is acidic. Right? The environment is really important to balance these things. Otherwise, it's not going to be a real-life application. It's not going to work. So whether the solution is acidic or basic is important, and that's also taken into account. Right? Do you see this in this very last step? If in basic solution, you got to do something. Right? So they're assuming the solution is acidic. And it's only if it's in basic solution do you do step 6. But let's check this out and see how this works. So I put it on the overhead over here so I don't have to go back and forth. And you also have you can tear out your rules yourself. But split the unbalanced equation into 2 half reactions is the first thing we're supposed to do. So 2 half reactions. All that means is break it up into the reaction that's producing the electrons and the reaction that's reacting with the electrons. And you don't even see the electrons. You just see, okay, I've got zinc on this side and zinc on that side. So I put zinc on this side and I put zinc on that side. Right? It's not that bad. And then the other half reaction would just be what going to what? The NO3, the nitrate, going to N2, nitrogen. So breaking it up into its half reactions isn't so bad. Okay? And then the next step. For each half reaction, perform the following steps in order. Balance. Now this is what's important. Like the solubility rules. You got to do it in order. Otherwise, the game plan isn't going to work. So do it in order. First, we balance all atoms but O and H. So leave O and H for last. So let's zinc, zinc. Done. All right? Well, let's just do the zinc one first. Balance O by adding water. There's nothing to do. We're just going to do the top half reaction first. The zinc going to zinc plus 2. Balance H. There's nothing to do. Balance the charge. Now, finally, step 4. Balance the charge by adding electrons to the appropriate side. And I changed appropriate to the most positive side because electrons are negative. So if you're going to balance charge, you have to add to the most positive side. So what's more positive, the zinc or the zinc plus 2 side? The zinc plus 2, right? So I'm going to add how many electrons to make the charge the same on both sides? What's 2? Because the charge on the zinc, everybody, is 0. Get used to that, right? If you don't see a superscript up there, it's 0. So I have to add 2 E minuses to get 0 on both sides. It's not always going to be 0 on both sides. It just has to be the same on both sides. So in that case, it's got to be 0. Okay. So this half reaction, the top one, the zinc one, is done. We've done all the little steps to balance that half reaction. Now let's balance the nitrate half reaction. Go back up to the top. Balance all atoms but O and H. So that means, right, just the N. So I would put there you go, right? And then balance O by adding H2O to the right side. Okay, how many oxygens do I have on this side? Everybody see it? 6. So how many waters do I have to add over here? I have to add 6. Right? Because each H2O has only 1 oxygen. So I have to add 6 O's, 6 waters. Stop me if I lose you here. Okay. And then now you balance the H's by adding H pluses is the next step. Well, how many H's on this side? None. How many on this side? 12. Yeah, 12. So add them to the right appropriate side. That means dump them over here. 12 of them. Okay. Okay. Now we're on step 4 there. It'll balance a charge by adding electrons to the most positive side. This seems to confuse folks a lot, this getting charge idea. So let's see if we can figure this out. What's the total charge on this side? Here's 0? Oh, okay, we're getting close. If I have 12, just look at the 12 H pluses. Just isolate them. Each H plus has a positive 1. I've got 12 of them. So just here alone, I have a positive 12 right here, just sitting there. That's positive 12. What's sitting right here? A negative 2, right? So I've got a negative 2 there. I've got a positive 12 here. The total would be positive 10. It's not that straightforward to see charge. It's confusing. So each H plus has a positive. I have 12 of them, positive 12. Each nitrate has a negative. I've got 2 of them, so that's a negative 2. Well, positive 12, negative 2, positive 10. How about the product side? What's the total charge here? What's that? It's neutral. Everything's neutral. Everything is 0, right? Because all we're doing is taking the stoichiometric coefficient, multiplying it by the charge. Well, 6 times 0 is 0, plus, well, 1 times 0 is 0. It's just, everything's 0 on that side. Everything's neutral. So this side's 0. So add electrons to the most positive side so that you get the charge to be the same on both. So electrons definitely to the reactant side, but how many? 10. 10 of them. Right? Yeah, it's going to be a negative 10 because each electron's a negative. But you're going to add 10 E minuses. I guess I got to squeeze it in here somewhere. 10 E minuses over here. Now I have the same charge on both sides. So right now, I'm right here. I have 2 balanced half reactions. Their charges are balanced on each, right? They're all each balanced. The charges are balanced, everything's balanced about them. Step 3, multiply the half reactions by appropriate factors. Because the big picture here, if I can erase all this stuff, the big picture here is when you work these out, line up those arrows. Because all we're going to do is add this stuff up. If we add up two balanced things, we get a balanced answer. That's the whole objective. Those half reactions are balanced. All we're going to do is add them up. But you can't have little electrons floating around. You got to cancel them out. And that's the reason for this step 3. Multiply the half reactions by appropriate factors so the electrons will cancel. Okay. So I like to put little parentheses around everything. So I'm going to multiply through each one by something so I can get electrons to cancel out. Do you see what it's got to be? What number do I have to multiply through by? Because right now, if I add them up, this is what I guess you have to see it this way. If I add them up right now, let's see, these guys would cancel with these guys, and I'd be left with 8. All right? So I have to do something to fix that. Multiply the top one by 5. All right? Because then I'll have 10. Okay? And though I guess technically the bottom one times 1, but okay. Now, this is what I like to do now is I like to multiply and add them up. In other words, don't rewrite this whole thing again. You can if you want to. You can write 5 zinc and 5 zinc plus 2s and 10 electrons. You rewrite this whole thing. But I think it's cleaner if you just see, okay, I have to 5 times the zinc. All right, I'm going to add up all the reactants and put them down here. I'm going to add up all the products and put them on the product side. So I have 5 zincs. Oh, I should cancel these guys out. All right, 5 zincs, and then the bottom half reaction plus 12 H pluses plus 2 NO3s. All right, the product side is going to be what? Let's pick on, see if someone's following, see if you guys are following. Victoria, what's the product side going to be? Yeah, an N2 and 6 H2Os and add up that and the 5 zincs. Right? See how the order doesn't matter? Because 6 plus 7 is 7 plus 6. We don't care. It doesn't matter. Yeah. It really doesn't matter. Okay. And now what you're supposed to do is step 5. Well, we're supposed to add the half reaction while canceling any common species. So I don't know, if you're getting that good, you might have some waters on each side, you can cancel them. But I kind of do that in this last step and then I rewrite it. But if you want to cancel stuff as you're adding it, that's fine. But we're supposed to see if it's balanced. What seems to work for me is if the oxygens are balanced, then I kind of just move on to the next question. So instead of checking everything, you can check everything. Like 5 zincs, 12 hydrogens, 6 times 2, 12 hydrogens, 2 nitrogens, 2 nitrogens, 6 oxygens, 6 oxygens. David? On the top one, because I have to get, the only reason for multiplying through by anything is to get the little E minuses to cancel. That's the only thing you look at. So when you're looking at it, I've got 10 on the bottom one, and I've got 2 up here. The only way to fix it is to multiply the top one through by 5. Because then I'll end up, actually I could have just, right, because I'll have 10 electrons there. I'll have 5 here, 5 there, right? See that? Oh, and another thing that you can notice is if you're working this and you need to have electrons canceling out. You need to have electrons on the reactant side, and you need to have electrons on the product side, right? If you do a half reaction and the electrons are on the product side up here, your other half reaction, they better be on what side? Otherwise you messed up. They better be on the reactant side. Otherwise you messed up somewhere, right? So that's another thing that you keep an eye on. Okay. And then we're on step 6 here, if in basic solution, but we're not. I mean, they said acidic, so we don't even do step 6. We don't worry about it. Okay? So let's do one more before I throw you off to the wolves here. Let's do, I don't know, let's just do C, all right, because it's just sitting there. Okay. Or doesn't D look even worse? All right, let's do D. Doesn't it? No, it just looks uglier. Okay, so I'm going to ask you, and you tell me what to do here. So follow the order. You can follow your handout or follow the overhead projector there. So Gloriana, what should I do first?
By Mn plus 2.
Oh, we're doing D.
Oh.
D.
Of course.
It's okay.
Zn.
Okay, Zn. Zn. Copy them verbatim.
Oh, exactly.
That whole thing.
Oh, okay.
Zn. I don't even know what the name of that thing is. OH4 and a -2 or something. All right? So just copy them. What we're doing is we're breaking them up into their, what do they call it? Half reactions. Right? We're breaking it up into its half reactions. How about the other half reaction? Christina, what would that be? NO3 minus 1 going to NH3. So breaking up into its half reactions isn't so bad, I don't think. Okay, Desiree, what do you want? What do we do next? So we are right here. For each half reaction, we're going to balance them. Balance O, balance everything but O and H. So are we okay for this one? Balance everything but O and H. Yeah, because there's one zinc on both sides. Ashlyn, let's just balance this top half reaction, and then we'll balance the next one. Okay? So after balancing everything but O and H, you're supposed to balance O by adding H2O. So for that top half reaction, what would you do? 4 H2Os to the reactant or product side? All right? The reactant, because the product side is the one who has 4 O's on them. So we need to add 4 waters over here. Okay? And now, Maria, we're supposed to balance H, bless you, by adding H pluses. On the reactant or the product side? The product. Yeah, the product side's short. It's short how many H's? Bless you. Is it 2? I hear 4. Yeah, right. See that? There's 8. 4 H2Os is going to give you 8 hydrogens. While the OH with the little subscript 4 is only 4 of them, so you're short 4 hydrogens. You can't write 4H, you have to write 4H plus. All right, now we're supposed to balance charge by adding electrons to the most positive side. So my reactants, Stephanie, my reactants there, what's the total charge on the reactant side? 0. Good. This side's 0. And then on the product side, Lauren, what's my total charge? Add up the charges, add up the superscripts. If you have just the zinc OH4 compound there, what's the charge on it alone? -2. You've got a -2, and how many H pluses? 4 H pluses. So with the 4 H pluses, just the 4 H pluses alone, you've got what charge? +4. So you've got a +4 and a -2. You end up with +2. I don't know what someone said, but you end up with a +2 total over here. Okay. So do you see how we got that?
Can you explain it again?
Okay. When you see any compound, you look right here for the charge. If nothing is written, the charge is 0. If something is written there, it's a +2. If something is written out front, now you've got what charge? +6. You get 3 of those, right? If you made it even more complicated, what charge do I have? I've got... Always look where for the charge? Right? Whatever it is, you always look right here for the charge. The charge has to be what? On -3, right? The charge is always sitting up there. Right? That's always the charge. Now what's the charge? 0. Now what's the charge? -21. See the game we're playing? All right. So okay, now we have to balance the charge by adding electrons to the appropriate side, the most positive side, Taylor. So we're going to add electrons to the most positive side. We should add how many and where?
Add electrons to the product side.
To the product side. And how many? 2 of them. All right? Because both sides in this case have to be 0. Yesenia, we're done with that top one. So now you have to do the bottom half reaction. So balance everything but O and H. It's done. Good. Erica, now we're on to balancing O's by adding H2O. Add 3 H2Os. To what side? The product side. I'm kind of getting my colors messed up, but that's okay. 3 H2Os. Now we're supposed to add H's, balance the H's by adding H pluses. Paulina. H's by adding H pluses. 6 to the product side? Sorry, 6 to the reactant side? Does that work out? It takes into account the waters, but we forgot about the ammonias. It'd be 9. Yeah. Does everyone see what she just did? She caught it. Yeah, there's 6. There's 6 from here, but you have to don't forget about those 3. So you've got 9 total. Okay. Your favorite, the charge. David, we have to balance the charge by adding electrons to the most positive side. Okay, what's the charge on this side? Positive or -8? Positive 8. You see how he got it? 9 positives and a negative. Positive 8. And the product side, everybody? 0. Okay. So we're going to add how many electrons then, Jessica? And where? Now, electrons are always going to go to the most positive side. And you keep adding them until it's the same charge on both sides. So the most positive side is going to be our reactants. You see it? And each electron's a -1. How many? It's going to be, right? So we have to add, our charge isn't the same on both sides. So we have to balance it by adding E minuses, electrons. So we definitely have to add them over here, to the reactants because it's the most positive. If you added just 1, it's only going to bring it down to a positive 7. Add 2, it'll bring it down to a positive 6. See the game? You have to add not 1, not 2, but 8, right? Make sense? You have to add 8 negatives. Because a negative 8, right? You multiply the stoichiometric coefficient times the charge to get the overall charge. It's just like 8 H pluses would have been positive 8, right? 8 F negatives would be minus 8. So 8 E minuses is a negative 8. So negative 8 and positive 8 is 0. Okay. Now we have to do that last step. We need to add stuff up. Let's clean this up a little bit. We want to get those electrons to cancel. So multiply by, Brianna, do we need to multiply by anything? There's no rule that says you have to multiply through by something. Do we have to multiply it by something? Yeah, because they're definitely not going to cancel. Right now, you'd cancel the 2 electrons, you end up with 6 on the reactant side if you added them up right now. So we got to multiply through by something, Jacqueline. What should we multiply through by? 4 on the top. Yeah. Multiply by 4. We could, too, just fix our... So make this guy... He's going to be an 8. There's nothing wrong with making this messy, because our real answer's down here, right? So we'll have an 8 there. He's going to cancel with him. And we can go ahead and change all of our little superscripts here. Coefficients. The 4 is now going to be a 16. The 4 is going to be in front of the zinc. The 4 is going to be in front of the zinc. And I'm going to have how many H pluses? 16. All right? Hey, man, by doing that, I can probably cancel my waters. Right? Because if you don't cancel your waters now, you're going to have to rewrite the whole thing again. Do you see that? I have 3 H2Os on the product side. That'll cancel and end up with how many? If I get all these guys to go away, I'm going to end up with 13. All right? End up with 13. Can I cancel anything else so I don't have to rewrite it? The H pluses. All right, so that means all these guys are gone. I'm going to end up with 9. 16 minus 9 is 7. I'll end up with 7. Man, what an ugly mess, right? But it should work. I think we cancel out everything we can. So now all the reactants, just add them all up, put them on the reactant side. All the products, add them all up, put them on the product side. And we're, right? And that's all. And it should be good. So we're left with 13 waters. So let's write that. We're left with, that's okay, 13 waters. And how many zincs? 4 of them. And how many of those nitrates? 1, yeah, because I'm not multiplying that one through by anything. And now I've got the 4 zinc hydroxide compound thingers. And I've got the 7 hydrogen ions. And I've got the NH3. And it looks like that's about it, right? Okay. Now, does that make sense? And it's kind of ugly up there, right? So it might be easier to... That's why I usually don't do it, because it gets too ugly up there. But if you can, you do what works best for you. Can we quit? No, because this is in what solution? Basic. So now we have to do this last step. we have to do this last step because it's not an acidic solution, it's basic. It's a basic system. So now it says convert all the H pluses to H2O by adding an appropriate number of hydroxides to each side. So all we're doing is, for example, if you had one H plus, add an OH minus to it, and what are you going to make? H2O, HOH, which is H2O, right? Okay. But he's nice and balanced, so we don't want to mess this up. How many, do we have any H pluses? If we don't have any H pluses, we don't have to worry about it. We've got 7. So we have to add how many OH minuses? 7. So I kind of like to do it this way. Otherwise I have to do all this extra writing. I'm going to add 7 hydroxides here. I have to add 7 to this side. Otherwise, I just messed it up. If I add something to one side, I better add it to the other side. Otherwise, it's not going to be balanced anymore. So you have to add them over here. And then to save myself from writing this like 3 times, I'm going to circle this, cross it out, and write what? 7 H2Os. That's exactly what I'm thinking. So I just made 7 waters. Now before you go on to the next question, you see how you're going to get a point taken off? This can be simplified again. I take away, exactly, like David said, take those 7 waters away from the 13 waters because, all right, you can simplify it even further. This guy goes here, you got 6. Now I would probably rewrite this thing because we can kind of see it. I could grade that. I don't think I'd take any points off, but it might be better. It might be better to write it so you don't take any chances. So 4 zincs and a nitrate and 7 hydroxides is going to give me 4 of these zinc guys and ammonia. Okay, and that was so much work. I hope and pray this thing is balanced. And like I said, the only thing I really mess with checking are the oxygens. So, do you see how many? This is a good practice. How many oxygens do I have on the product side? How many oxygens do I have? How many oxygens? I've got 16, right? Because I've got 4 of these guys, right? 4 times, because for each one of these compounds, I've got 4 oxygens. And I've got 4 of them. So you pretty much have to multiply it. I've got 16 oxygens over here. How many oxygens? So here I've got 6 O's. Here I've got, 7 O's here. And the nitrate gives me 3 O's. 6 and 3 is 9, plus 7, 16 O's. The O's are good. Let's practice with the charge. That'd be a good practice. The charge has to be the same on both sides. Doesn't have to be 0, just has to be the same on both sides. This is a good one. Let's go back to my green color. What is the total charge on that side? It would be -2 if I didn't have the stinking 4 there. But it's got to be -8 multiplied. So this side's -8. Yeah. Okay. -8. I better end up with -8 on the reactant side. Is there any charge with the water? No. Well, I guess I could write it underneath. I've got 0 here. 0 there again. The nitrate, I'll have a -1, and I got a -7. It works. All right? I mean, there's no way you could arrive at this answer randomly. This is an ugly, ugly balancing. Okay, we've got about 5 minutes. See if you can knock out, let's do an acidic one, because I don't know if you'd have time to do a basic one. Try this one. He's not so bad. He's not near as long or as ugly. Try B. B as in boy. And you can tear out your rules or just follow this thing. So first step, break them up into their half reactions. That's the first step. Break them up into their half reactions, and then balance everything but O and H. That's the next one. Balance everything but O and H. Mm-hmm. Okay, you have to see how many O's are on this side and how many O's are on this side. If it was just like that, if you have the same number of O's on both sides, there's nothing to do. But here you have 3 O's. Well, only 2. 2 H2O's. Yep. Yeah, it's going to go to the NO. Good. Good, you got it. Okay, now you have to balance the H's by adding H pluses. If you didn't, you're right, if you didn't have that 2, it's going to be 4. Right. So you got the 3 O's. You only have 1 here. It has to be 2 H2O's. Yeah, so N's are done. And N and an N, there's nothing to do. And the CU's are done too. There's only 1 on each side.
So this doesn't matter?
We're not there yet. That's charge.
Okay.
And do them in order. So you balance O by adding H2O. You have 3 O's. Don't you have 1 already though? So it's only going to be 2. Don't forget about writing your little charge on the nitrate, right? Because then you're going to have 0 on this side. Yeah, you would have been right. You would have been right if you didn't have that guy as a negative.
Okay, so just change that.
Yeah, so you're going to have a plus 3 on this side. There you go. There you go. You got it. The most positive side. So you've got a positive 4 and a negative. That's a positive 3. This side 0. You have to add E minuses to that side. To the most positive side is where you add the E minuses. Yeah, don't forget your charges though. They're really important. That has to be a minus. That has to be a plus. And you got it. Now you can do the charge. This whole side 0. This whole side is positive 4 and a negative 1. It's going to be positive 3. Right? Yeah, you can. Yeah, you can write anything you want. So that side's going to be positive 3 total. Yeah, because that's a 4 and negative 1. And you have to add E minuses to the most positive side. This one's 0, that one's positive 3. You have to add it to that side. And you want to make them the same on both sides. It's the charge. So you can add how many E minuses to positive 3 to get it down to 0? 3 of them, yep. Okay, so we're about out of time. But come by and I'll be glad to help you out with this stuff. You can pick up your exam retake and whatever else is in your folder. Yep.
reactions are.